Hello, my name is Taylor, and welcome to another video of the Bowl of Chemistry Knowledge. The topic of today's lesson is properties of inorganic acids. Hundreds of books and thousands of scientific articles have been written on this very topic, as it is very extensive. This is why today's lesson will discuss only the most important properties of inorganic acids. Let's start. Acids are chemical compounds which, depending on the adopted theory, can be described as hydrogen cations producers, hydrogen cation donors, or electron pair acceptors. Attributes of acids. Acid solutions have a pH level less than 7. They tint the universal indicator strip red. Aqueous solutions of acids conduct electricity. Chosen properties of acids. They undergo an ionic dissociation reaction, a decomposition into ions. Acids decompose into positive ions of hydrogen and negative ions of the acid residue. The general scheme of the dissociation reaction applies to both oxyacids and anaerobic acids that can be presented as follows. Under the influence of water, the acid decomposes into hydrogen cations and anions of the acidic residue. In fact, dissociation follows the second pattern. Hydrogen cations combine with water molecules to form hydronium ions, H3O+. If acids contain more than one hydrogen atom in their molecule, they undergo multi-stage dissociation. How many stages are there? There are as many as hydrogen atoms in the molecule of a given acid. Sulfuric acid contains 2 hydrogen atoms, and therefore its dissociation process takes place in 2 phases. In the first phase, one hydrogen cation and an anion of an acid residue still containing one hydrogen are formed. And in the second phase of dissociation, another hydrogen cation is separated, and the SO42- anion is formed. To present this process in a more realistic way, the diagram looks as follows. Basically, both versions look identical when it comes to acid residues. However, the difference is in showing the formation of hydronium ions, H3O+, instead of the usual H+ cation. In the case of H3PO4, this process will take place in 3 stages due to the fact that this acid contains 3 hydrogen atoms in the molecule. Therefore, in each subsequent stage of dissociation, another hydrogen will be separated. And the same process showing the formation of the hydronium ion. It has already been said today that both oxyacids and anaerobic acids dissociate, and that dissociation occurs gradually if a given acid has several hydrogen atoms in the molecule. Now, another very important topic, dissociation and acid strength. It is the dissociation process that determines whether an acid is considered strong or weak. It is generally accepted that strong acids are completely or almost completely dissociated. However, acids that have a low degree of dissociation are called weak acids. Look at the bar diagram for the dissociation of strong acids. It is assumed that in the case of strong acids, acid molecules marked as HA in the diagram decompose into hydrogen cations and anions of the acid residue under the influence of water molecules. More precisely, into hydronium cations and anions of the acid residue. The situation is completely different in the case of weak acids. Under the influence of water molecules, part of the HA acid will decompose into ions, but part of it will remain in the undissociated form so as HA. How much HA and how many ions will there be? The weaker the acid, the fewer ions and the more HA there will be. Therefore, when writing down the dissociation reaction of strong acids, we write the arrow in one direction, and, in the case of weak acids, in both directions. When writing down the dissociation process, taking into account the formation of the hydronium ion, we follow the same rule for arrows. The dissociation constant, Ka, is used to classify an acid as strong or weak. The K constant is the product of the concentration of products, so ions that are formed during dissociation and the concentration of the acid that remains in the undissociated form. The higher the Ka constant, the stronger the acid. That follows the logic, because the more dissociated ions there are, the larger the numerator of the fraction, the higher the overall value of the fraction. And this is why strong acids will have high dissociation constants, and weak acids will have low Ka. Ka values for all acids are determined experimentally under given conditions, and the good news is that you do not have to memorize them. If you need these values, for example, for calculations, their values will always be provided for the task. When it comes to the dissociation constant and degree, as well as Ostwald's dilution law, the theory and problems on these topics will appear soon in the next videos. That is why I cordially invite you to subscribe to the channel so you do not miss the topics that are often required for tests and exams. To give you a general idea about the Ka values for strong and weak acids, I have prepared 2 samples of Ka values for you. Look how large the Ka value is for hydrochloric acid and how small it is for hydrofluoric acid. Hydrofluoric acid is mollusk compared to HCl, and I have an interesting fact for you about this mollusk. Did you know that HF etches glass? The first minute after pouring it into a beaker, the walls of the beaker become dull. At that moment, the breaker begins to leak. So how is this possible if, after all, hydrofluoric acid is such a weak acid? This happens because under the influence of HF, silica, SiO2, is transformed into a volatile SiF4. Therefore, etching glass is a feature of this acid and has nothing to do with its strength. It was an interesting fact. Let's go back to dissociation, so to the strength of acids. How does the strength of acids change in the periodic table? As the group number increases, so as the atomic number of the central atom increases. The strength of both oxy and anaerobic acids increase. Now attention, within the given group, anaerobic acids, group 17th, fluorine, chlorine, bromine, and iodine. In oxygen-free acids, the strength of the acid increases as the electronegativity of the central atom decreases. Therefore, the most electronegative fluorine creates a weaker acid, and the least electronegative iodine creates a stronger acid. Looking at the arrow, the power increases down a given group. Now, when it comes to oxyacids within the group, the situation is exactly the opposite. The strength of oxyacids increases as the electronegativity of the central atom increases. So, as the arrow shows, we can say that within a given group, it is growing upwards. Additionally, if a given central atom creates several oxygen acids, the strength of these acids increases with the increase in the number of oxygen atoms in the molecule. This is clearly visible in the example of chlorine acids, where the strongest of the chlorine acid, which contains as many as 4 oxygen atoms. Well, that's enough talking about strength and dissociation. Let's go back to the properties of acids. When it comes to the properties of acids, we already know that they dissociate. Acids react with metals. The products of such reactions depend on both the metal and the acid. Sometimes a reaction of an acid with a metal increases hydrogen, sometimes other oxides, and sometimes a reaction does not occur at all. These types of reactions are influenced not only by the properties of the acid, but also by the type and the nature of the metal. The general rule is that the more noble the metal, the less active it is, and vice versa. The topic of dissolving metals and various acids is extremely important. It often appears in tests and exams, so it cannot be discussed in just 2 sentences. I've decided that the next lesson, which will be published soon, will be focused on the dissolution of metals and acids, and then I will discuss in detail how these reactions take place. If you have a chemistry exam ahead of you, you cannot escape this topic. If you are preparing for a chemistry exam, I invite you to subscribe to the channel. Then you will not miss this topic. To make sure that this property of acids is not completely ignored in this video, let's look at 2 examples of acid reactions with metals. If we throw zinc into hydrochloric acid, the metal will dissolve, and one of the products of this reaction will be hydrogen. I present to you the molecular and ionic recording of this reaction. If we throw copper into hot concentrated sulfuric acid, the metal will dissolve, but no hydrogen will be released in this reaction. In this reaction, according to the written equations, the gas released will be SO2. Other metal dissolution reactions will be presented in detail in the next lessons of inorganic acids. Guys, now another interesting fact. Did you know that the extraordinary liquid that has always fascinated alchemists, known for over 1,000 years, referred to as royal water, is a mixture of concentrated acids? It is a mixture of concentrated HCl and HNO3 in a ratio of 3:1. Its fumes are highly toxic because they emit a very toxic oxide that irritates the mucous membranes of the eyes and respiratory tract. Royal water has very strong oxidating properties. It dissolves, among others, gold, palladium, platinum, and other precious metals. Therefore, never throw your favorite gold signet ring or ring into this magic water because it will disappear forever. Alright, let's go back to another property of acids. Acids react with metal oxides. As an example, I choose the reaction of sulfuric acid with CuO. The products of this reaction are salt and water. This is why the reaction of metal oxide with acid is one of the methods of obtaining salt. The 4th important property of acids is the reaction with hydroxides. The reaction between an acid and a hydroxide is called a neutralization reaction, and its products are salt and water. While earlier mentioned reactions are sometimes written molecularly and sometimes ionically, neutralization reactions are written mainly ionically due to the nature of these reactions. Depending on how strongly acids and hydroxides react with one another, the resulting salts may be acidic, alkaline, or neutral, but this is a matter of pH, a topic for another lesson. We have therefore discussed the quintessential of the 4 most important properties of acids. Guys, that's all for today. Thank you very much for watching this lesson until the end. I invite you to leave comments and subscribe to follow the next videos with new topics. Thank you very much for today, and see you in the next video on the Bowl of Chemistry Knowledge.